Yo, basically in this video we're going to be doing what I said in the previous video, so if you haven't seen that one, I mean, check it out. There'll be a link in the description below. Always check the links below, there will be something interesting below. So first thing I want to do is create my perimeter calculator. So I'll come up to Spider, or whichever one you're using. You might be using PyCharm. I'll create a new module, def space perimeter self. Now for rectangles, I know the perimeter equals 2x times 2y, yeah, because this and this are the same and that are the same. So to do that, I say self.p, so I'm creating a new variable, new instance variable, equals 2 times self.x plus 2 times self.y, enter, and then return, this is key, self.p. So I'm not putting print because I don't want it to print it, it will print the output. This is just giving me an output, and whatever I run with this will print this. It's the printing in the other program because I'm not running this as a program. Then I will press F5 to save and run it. It's good to do that instead of just saving, because if it runs like this, it means everything's good. There's no mistakes, there's no missing colon, there's no accidental tab. Yeah, okay. So same thing as this basically. I'm actually going to copy just this because, press Control C. We're going to give it the same two inputs. Like, there's nothing different. We're going to use the same class and we're going to give it the same two inputs. Where we differ is we're going to give it a different module and we're going to name it something, a different column. So R bracket quote mark perimeter, remember to close everything, equals Control V, so eng.rec, and then your two values going in, and then we need to tell it which command we want, because as I said before, we used the area command before, and now we're going to use the perimeter command. Before you continue, you're going to have a problem. In fact, I'll show you the problem. Dot perimeter, and then I'll press enter and say print R. This isn't going to work, and I know why. I'll tell you in a minute, but I'm going to show you. As I have said, didn't work. This has been saved, but Jupyter hasn't taken in the latest module. So I'll say kernel, restart, and run all. That way it will just run everything. I don't have to run each one. Now it works. There are your perimeters in millimeters. Or forget units. Just all that's done is to multiply 2 times this by 2 times this. So now let's assume these are all cross sections of beams, concrete beams for you engineers. Let's say yeah, let's say they're all these cross sections, so that's your x value, this is your y value, as it says there, your z value in meters. Let's say I want to know the areas in millimeters. Yeah, in meters squared. Sorry, the areas in meters squared. So I want to convert these to millimeters before I do anything with them. I could divide these all by 1,000 using the same technique I showed you in the first video in terms of multiplying 2. I could just divide this whole area by this whole row by 1,000, or even in this case it would be by 1,000 times 1,000, which is 100,000, or a million, whatever. Anyway, that ain't the point. The point here is I want to convert these before they're multiplied, yeah? And what I could do is I could create new rows where these are all divided out and then use those to calculate the area, but I don't want to do that. It's a waste of you're just going to create rows for nothing. I want to put the calculation inside here, yeah? So how do I do that? I want to first create my own new class, call it unit underscore C. It's representing unit convert. So I'll initialize it, and I'll say comma X. It just needs one number to come in. We'll just give it the name X. It doesn't really matter that we've named something else X. This is a completely separate module. And then self.x equals X. And I'll create a module here called def underscore m. Oh, and I forgot to add the self to tell it it's part of this program, where it will take in the self values. And all I'm going to say is L, or self.L equals self.x divided by 1000, and then return self.L, and I'll press F5 to run it. All good, and it's saved as well. Now kernel, restart and run all, and we haven't done anything with it here, but what I'm going to do is I'm going to sorry, I've cut the video a little bit back because I made a little mistake. I tried to type this in here to replace that, and I had some issues. So what I need you to do, basically what this does is that little unit, that one I made, underscore m, remember to restart your kernel, restart and clear outputs if you haven't done so, to make sure it's loaded in. This has converted all of the x's to meters, from millimeters to meters, yeah? What I need to do now is I want the area to be calculated in millimeters squared. So I want the x's and the y's to be converted to meters before calculating the area. And I don't want to create a new row with them as meters because it's a bit long and unnecessary to have so many rows, and we are going to export this as an Excel spreadsheet. So how do I do that? I can say, so what I've done, I've created a new row, but instead of doing that, I'm going to give this a variable name. We're going to call it X. And when I run this command, well, I need to restart. The reason I need to restart is because that row was already made by that column, and now when I run it again, it won't make it. And now I need to tell it the same thing. I'm gonna do this, Control C, Control V. I'm gonna tell it Y equals Y, and run that. Now, I can now change these because now I've told. You know what? I'll even give them a name just to make them easier to understand in the future. Y underscore mm or X underscore mm, just to tell it that those are in millimeters, not meters, and we'll make new ones where X and Y are the values in meters. So X equals, and we will say this, Control C, y equal Control V. Now, this entire row, I don't need to type that longness anymore. It's a bit long. So, because we've given them these variables, yeah? So, now, when I calculate the area, I'm just going to show you just X and just Y. It still works. Because all I've done is I've told Jupyter that X is now representing this column. So this column is represented by this variable. Yeah. Now I want the areas in millimeters. So underscore mm area. Boom. Done. Nice little conversion. And the perimeter will work in millimeters. That's what I want to know anyway. I'm just going to change these to convert them to what we're doing now, X and Y. And I could change these to X underscore mm if I want. Sorry, I've represented them wrong. X underscore m to represent meters. They're not in millimeters, yeah? And these ones we'll just assume that if they're in, everything's in millimeters. We'll just assume that the normal ones are in millimeters, but we know they are. So I'll kernel, restart and run all, and there you go. And remember, when you change things like that, to change these. Because they no longer exist. Right, so as I said, you could, I'll show you another way of converting all of these if you wanted to do it this way. If I wanted the perimeter in both millimeters and meters side by side, I would say, I'll just copy this, Control C, Control V, and say perimeter underscore meters equals this one. I'm not going to create a variable for that. I can either divide it by 1,000 like this, or I can apply my module to it. Where is it? Def underscore mm unit underscore c. So just to show you, I mean, really and truly I would do it this way, but I want you to know that you can apply it this way. So I can say eng.unit underscore c. There's my number coming in. Each one of those dot mm underscore m open close bracket. There you go. It's ran and the value is the same. Yeah. Now I want to export these as an Excel spreadsheet. So I say R. This is why we bring in the data set as a variable, so that we can do things to it like this. So I want to take this data set, R dot, what was the command? There you go. The command is called to underscore Excel. Now I want the location of where I want to place it. Same location as this. In fact, let me take in the quote marks. Control C, Control V, and remember at the end of the quote marks to add the name that you want to give it. So I will give it fid dot xlsx. It's very important to put the file type at the end. And just to show you, I'm not lying, there is no spreadsheet in here called fid. In fact, I'll show you side by side. Oh, okay. There it is, there, created. Press shift and enter on that little one of those. and here is all my data that I made as numbers. No formulas, but don't worry, the formulas are in Jupyter. Now, before you go, I'm going to show you something very important. Let's assume these numbers change. You can see all of those changed. All I have to do is go to Jupyter, and I don't even need to restart the kernel. I can come here and hold shift, press enter. Oh, sorry, I forgot to save. Make sure you save this. Not that one. Save. Make sure you save before you edit it. There is the new data, matching exactly what we have there. And now I can just run through. I could even run them all using the kernel. And because I didn't change the file name here and I closed FID, it's actually changed it to match the new data. Let's open it and see. Yep, you see? New data, new stuff. And obviously if you want to give it a different name, you give it a different name there. Here. I hope you enjoyed that. I hope you learned something. Please do like, share and subscribe. Tell all the nerds, tell all the engineers. This is the this is the present actually. You need to know this. This is better than MATLAB, better than anything. If you're a university student, I actually think you can even use this as part of hand calcs because you haven't used the software. As long as you've written the code, legally speaking, I think they would have to class that as hand calcs. So, knock yourself out. Please do check my next few videos, and I hope to see you again soon.